Hello everyone. In this video, I will demonstrate how to solve a problem based on line balancing. So we have been given a set of tasks and we need to assign these tasks to the workstation in such a way that we will minimize the percent idle time of the line and maximize the percent efficiency of the line. So basically, we have been given task A through J. We have to assign these tasks to the workstation. Uh, Most oftenly, it's an assembly line where you have workstation in a sequence, and all these tasks will be performed on those sequentially arranged workstation, and we have to do that in such a way that again we maximize the efficiency and minimize the percent idle time. So that's an objective here. Okay, so we have been given a set of tasks, and we all have also given that operation needs to achieve an output of 500 units per 7-hour day. Now this duration that you see in a table, by the way, this is problem number 7 on page number 293, chapter number 6. Okay, these times are in seconds. Okay, so we have to convert, when we calculate the cycle time, we would have to convert 7 hours into seconds. Okay, and we will deal with that going forward. Okay, so again we have to do task A through F. E not needed, so we'll do those tasks here, and we are always going to follow these rules. Okay, so rule number 1 is assign that task first which has greatest number of hours. Okay, in case of a tie, assign that task first which has longest process time requirement, and if you cannot fit in that longest time requirement task, try to fit in the other one. Okay, and if you still have a tie, then you can break the tie randomly. Okay, so these are the rules we are going to follow. So let's do the first thing, draw the precedence diagram. So looking at this table, we see that task A does not have any immediate predecessor, so it's a starting activity, and so is task D is a starting activity. Okay, and other details are given here. Okay, so let's do it, and we have to do it faster because you had to do this in an exam, and again in exam you can use this template. Probably that will speed up the process of solving the problem. So let's go ahead and do this one here. So I'll draw a small circle here, and this is my A, right? And I need a text box. Okay, and that will 45 seconds. Okay, so I need 1 2 3 4 5 6 7 8 9 10. Already have one, so I need to copy this one. So I will select the top one first and then bottom one. Then control V. 1 2 3 4 5 6 7 8 9. That should do. Okay, so let's start moving there somewhere in the places. Okay, so we don't know how this is going to look like, but I will randomly arrange them to start with, and then we'll see how we can deal with it. Then move this one here. So we try to arrange it. So those things you have to be literally aware of those things. Okay, so first is, let's say, uh, activity A takes 45, B follows A, right? So and takes 11, so this will be B here, and this will be 11. Okay, so I'll just move it closer to the activity. Okay. Now C follows B as well. So this is C follows B, and then D is by itself. So let's say D is going to be here, and it takes 50 seconds, right? E follows D, so this is my E here, and E takes 26, all right? And then F follows E, okay? G follows C, and H follows C. So this is my F. Let's say this is my F, and it takes 11 seconds. And then G follows C, and H follows C. So let's say this is my G, and G takes 12. This is H, and H takes 10. I takes I takes 9. J takes 10. So let's connect this one now. So I will use insert arrows here. Insert. This is quite faster now. C follows B, and then we know that G and H follows C. So let's connect those. G and H follows C. E follows D. So let's connect that. E follows D, and F follows E. Right? And then I follows F, G, and H. So let's connect that. So you would have to practice this one so that in the exam you can do it faster, okay, because you are required to use Excel. So this is our precedence diagram that tells me all the activities, their respective times, and their interrelationship. Okay, so we are done with the precedence diagram. Okay, it's fairly easy to do it. The next thing is we have to find the calculated cycle time, which is the operating time per day divided by output. And as I discussed before, these durations are in seconds, so we would like to have cycle time in second. Basically, this will tell me how much time it takes in seconds to produce 1 unit. Okay, so that will be equals to, we have 7 hours a day, so 7 times 60 minutes times 60 seconds, right? And divided by 500 units, right? 500 units. So it's always best to put in parentheses to avoid any confusion. So it's going to take 50.4, not minutes, but this is seconds. Okay. So this our calculated cycle time is in seconds, right? So this is the minimum time each workstation is going to take. Okay. So since we okay, let's stick with 15.4 here. Okay, so now how many workstation we are going to need at the minimum? So that will be given by this formula, summation of task time divided by calculated cycle time. So that will be equals to sum, let's say sum of all this times here. Okay, my sum is not working, so let's try it again. Equals sum of all these numbers, right, and divided by calculated cycle time. That should give me 3.82 workstation. So it cannot be in fractions, so we would round it up to 4 workstation. So that's the minimum number of workstation. WS stands for workstation. Okay, so there's a minimum number of workstation you are going to need, but after assignments you might need more. We don't know yet. Okay, so just keep that in mind. So now let's get started. Let me squeeze in some place here. Let's say I'm gonna delete this row here. The reason I'm doing this is, because I want to see the diagram while assigning the task. Okay, so workstation number 1 will always take 50.4 seconds. These are all in seconds. Seconds, 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 and so do it here, seconds. So eligible tasks are A and D because they don't have any task preceding them. Okay, so they are the starting activities, so they both are eligible. So rule number 1 says that count the maximum number of followers. Okay, so I guess I need to, since I collapsed the rows, screwed up my diagram a little bit. Okay, so count the number of followers first. So A has 1, 2, 3, 4, 5, 6 followers, while D has 1, 2, 3, 4 followers. So we'll assign A first because it has more number of followers. Okay, and A takes 45 seconds. So if you deduct 45 seconds from 15.4, you get 5.4 seconds. Okay, now you know that all the other tasks, they take more than 5.4 seconds. You see it in the diagram here, right? 11, 50, and henceforth. So we cannot fit in another task to this workstation. So idle time is going to be 5.4 workstation. And how much time this workstation has consumed in all? Well, if you deduct 5.4 from 50.4, you will get 45 seconds, which is the task time for task A, right? So that's how much time is totally consumed by this workstation because you only have one task in here. Okay, so let's move to workstation number 2. So 50.4, what are the eligible tasks here? A is already assigned, so I can assign B, and D is already eligible, right? So B has 1, 2, 3, 4, 5 followers, while D has 1, 2, 3, 4 followers. So I'll assign B here, and B takes 11 seconds. So if you deduct 11 from the 50.4, you get 39.4 39.4 second. That's how much time is remaining, right? Now we can fit in more tasks, 39.4 here. Okay, so what are the next eligible tasks? C and D, because A and B already assigned, so we can assign C, and D is already eligible. Okay, so C has 1, 2, 3, 4, and D also has 1, 2, 3, 4. So they have same number of followers. In case they have same number of followers, we need to break the tie by choosing that task which needs higher processing time. So in case D needs higher processing time, right? So D needs 50 seconds while C needs 9 seconds. But we only have 39.4 seconds left, right? So we cannot accommodate D. So as a result, we'll accommodate C here. Okay, so this is what you need to keep in mind in the exam. C takes 9 seconds. So if you deduct 9 from 39.4, you get 30.4 seconds. Okay. So let's do 30.4 here. So next eligible task are, since C is already assigned, we can now G and H are eligible as well. So D, G, and H. So we're gonna have D, G, and H. So D and G needs only 2 following tasks while D has 4, but we cannot assign D because we don't have as much time remaining. Okay, so we'll go to the next 2 tasks. They have the same number of followers, so I will choose the one that needs higher processing time, which is G. So I will assign G here. Okay, so G takes 12 seconds. So if you deduct 12 from the 30, you get 18.4 here, right? So 18.4. Next eligible tasks are going to be D and H. Okay, because they both were eligible. I is not eligible yet because for I to be eligible, you need to make sure all these 3 tasks G, H, and F they are already assigned. So is E. If E will only be eligible if activity D is already assigned. So neither are those 2 constraints satisfied yet. So let's go ahead. So next eligible tasks are D and H. So D has more number of followers, but we cannot assign D because we don't have enough time left. We only have 18.4 seconds left. So we'll go ahead and assign H here. H will take 10 seconds, so time remaining is 8.4 seconds here. Now we know that none of the activities like next eligible activity. So what are the next eligible activity? Since I'm done with G and H, I is not eligible because F is not assigned yet. So the only next eligible activity is going to be D, which is going to take 50 seconds. So this is the end of this workstation here. So idle time is 8.4 and total time is 42.8 42.4. Total time consumed is I would say 42 seconds. Okay, because you deduct 8.4 from 50.4 and you get 42 seconds here. Okay, so moving on to workstation number 3. To start with, we'll have 50.4 and the next eligible tax is only D. I is not eligible yet because for I to be eligible, as I said before, F needs to be assigned first. So let's go ahead and put that task D. We are going to assign D here. D takes 50 seconds, so time remaining is only 4 seconds. And that's my idle time because I cannot fit in E. E takes 26 seconds. The time consumed here is 50 seconds. Okay. So we'll move to number 4 here. So again 50.4 is the time available. Every workstation will have same amount of time available, which will be equal to the calculated cycle time. Okay, so since D is already assigned, next is E. So we are going to assign E here, and E takes 26 seconds. So if you deduct 26 from 50.4, you get 24.4 seconds. Okay. Oh, I'm sorry, I should be in here 24.4 here. Okay, here we are going to assign E. Okay, so let's move on. So we have 24.4 left. E is already assigned, so next eligible is F here, right? So we are going to assign F here. F takes 11 seconds, so if you deduct 11 from 24.4, you get 13.4. Okay, so that much time is remaining. We can fit in I because I will take only 9 seconds. So we'll go to here, 13.4. Next eligible is I. I is now eligible because we are done assigning G, H, and F. Okay, so we are going to assign I here. I takes 9 seconds. So if you deduct 9 from 13.4, you get 4.4 time remaining. We cannot fit in J, right? So that becomes the idle time from this line, and this line has consumed 46 seconds. Okay, so next workstation is going to be 5. To start with, we have 50.4 seconds. Only task that is remaining is J, so we're gonna we are going to assign j. J takes 10 seconds, so time remaining is 40.4 seconds, and that's your idle time because you don't have any more tasks left. Time consumed is 10 seconds. Okay, so this is how you would assign tasks to the workstations. Okay, so we are done assigning the task here. Next thing is we need to, let's delete this rows here. Actual number of workstation 1 2, so it's always, let's color this one. Okay, so it will be easy to identify. Okay, so every alternate I will color it. Okay, workstation, so that we know what those are, easy to recognize. Okay, so these are easy to recognize here. So number of workstation are actually 5, so minimum was 4, right? So minimum was 4, but we actually used 5 workstation. The actual cycle time is going to be equals to the maximum of all these times, and we know that it's 50. So that's a 50 seconds. Okay, so that's actual cycle time. So calculated cycle time where was quite near 50.4. In this case, actual cycle time is 50 seconds. Okay, so this tells again, the cycle time is established by the workstation that consumes most amount of time, because that becomes a bottleneck workstation, and that determines how many units are you going to produce in a given time. As I said, cycle time establishes the rate of output of a line in terms of how many units you can produce in a given time. Okay, so although cycle time is in time unit, that tells me how much time is going to produce one unit, but basically it establishes the rate of output. So percent efficiency here is going to be again I need to take the sum of my task time. So let's do that, sum of all my task time. Okay, and that divided by, I will use the parenthesis here, 5 times 50. So that's my an actual, and times actual cycle time, and whole, I need to multiply everything by 100 to have it in percentage. Okay, make sure you provide opening parentheses as well, otherwise it is going to generate an error. So line efficiency in this case is very low, it's 77.2%. Idle time for the line is going to be equals to 100 minus the efficiency, that's 22.8%. Okay, now as you see, this algorithm is not very effective sometimes. Okay, because here line efficiency is 77.2%, which is very low. Okay, something you have to keep in mind. Okay, this algorithm may not work always, but basically it tells you how in the real world tasks are assigned to the workstation. Okay, so with this I will end my lecture here. Thank you very much for watching.